All right, this is the second video for the metric system. In the first one, remember we looked at the idea of making the meter longer, all right, or multiplying it by tens. Now what we're going to do is we're going to make it even smaller. All right, and remember in the first one I said we were going to measure the distance from Madison School all the way to Blissfield, and the best measurement to use was the kilometer, which is 1,000 times the length of this meter stick. Now, what if I told you what I wanted you to do now is I want you to take a nostril hair out of your nose. So you got to pluck one of these guys out. Then what I want you to do is you're not going to measure how long it is. You're going to measure how thick it is. All right? So that's going to be pretty small. Could you use a meter stick and put that up to your nose like this and measure the thickness? Now, that would be like way too big. All right? So what we've got to do is we got to make this meter stick smaller. So what we're going to do is we're going to take this meter stick and we're going to cut it into 10 pieces. And one of those pieces would be about this big off that entire meter stick. So it's only that long, right? And what that is, going back to my scale back here, is that from the standard, that's a decimeter. And that's 1/10 times. So it's 1/10 of the length of that meter stick. Again, the bad part is that 1 decimeter, which is that big, if that's how thick my nostril hair was, oh my goodness, that would be really thick. Wouldn't even fit in my nose, obviously. So we got to go even smaller. So now we got to do is take that decimeter and we're going to cut it into 10 pieces. And one of those pieces would be about that big, right? And that's called a centimeter. And that's 1/100th times. Again, if you notice, all we're doing is adding tens to, or adding a zero to each one of these, because we're either multiplying or dividing by tens. So we go to a centimeter. That's this big. If my nostril hair was that big, it still wouldn't even fit inside my nostril. That's still pretty big, right? So we got to go even smaller. So we got to take one of these centimeters and cut it into how many pieces? 10 pieces. So we cut that and we end up with a millimeter, which is about that big, right? So that's my next step is millimeter. And that's 1/1000th times. Okay, and a millimeter is this big. If my nostril hair was 1 millimeter thick, then as I always like to joke about is, if I had 3 of them hanging out of my nose, I could actually take them and braid them together, right? Which you can imagine having 2 braids hanging out of your nose of nostril hairs. Oh my gosh, that would be like, I think I would have a lot of people staring at me, and probably not me, but staring at my nose, seeing my braids of nostril hairs hanging out of my nose. So it's still too thick. We got to go even smaller than that. Well, now, just like we did up at the top where we put the blanks in, now all of a sudden, instead of jumping by tens, we're going to jump by 1,000. In order to jump by 1,000, we got to put a blank in here. That's 1/10,000th. And then we put another blank in. That's 1/100,000th. And then we get to this one, which is micro. And that's 1/1,000,000th. All right. And if you notice, there's like a weird symbol right here. That's a Greek symbol. It looks like a U with an extra tail in the front. And I will tell you that when I type these things out on the computer, it won't let me do that Greek symbol, so I just use U. But know that really what it's supposed to look like is it should look like a U with a tail on the front. Okay. All right. Yes, on the front of it. So micrometer. That's taking that millimeter, that basically what would be about a pencil lead thickness, and dividing that 1,000 times. So cut that lengthwise 1,000 times, and one of those would be a micrometer. Now that would actually be small enough in order to actually measure the thickness of a nostril hair. All right, but the only thing is, in order to probably measure it, guess what we would have to use? A microscope. So we use a microscope to measure micrometers. All right, so all of a sudden things start to blend together in this actually. Now we can actually go even smaller than this. We can actually take that micrometer divided 1,000 times. So now I need 2 more blanks, and we get to a nanometer, which is capital N. And that's actually 1/1,000,000,000th times. And a nanometer, what that one's actually used, that's actually used to measure the distances of the atoms within inside of a molecule, like water. Water is H2O, and we can measure the distance between an oxygen and a hydrogen using nanometers, right? And that's 1/1,000,000,000th of a standard. That's taking this meter stick dividing it into a billion pieces, and one of those pieces would be a nanometer. Now we can actually, this is not in your notes and you won't have to know this, but we can actually go even farther, and we can go another 2 blanks and another one, which is picometer, which you are starting to see picometers in science and in business now, which again, that's actually 1/1 trillionth of a standard, or taking the meter stick, dividing it into a trillion pieces, and one of those would be a picometer. And if you look up online, you can actually do this again if you want. You can check, and it actually goes even further. You can go farther down, almost indefinitely, because all it is dividing by 1,000 each time, and you can continue on and on and on and on and on. Right? So we can take this metric unit, and we can either make them bigger, like the idea of your cell phones, where you got megabytes, gigabytes, and terabytes up here. Right? So again, you guys know this. You guys know it better than I do, because you know that. You're not going to buy a 4 megabyte phone, because it's not going to have any kind of memory in order to take pictures or store songs or do anything. You want a gigabyte phone. You want a phone that's got 4 gigabytes or 8 gigabytes or 128 gigabytes, right? Or even better, how long is it going to be before we have phones that have terabytes? Being that we have computers with terabytes, I don't think it's going to be long before we're going to have phones with terabytes, right? Quote me on that. We'll see. Like I said, I don't think it's going to be long. When I say don't say not long, I'm going to say within a couple of years, if not even before, that we will have phones. Now we can go the other way again. We can make things smaller, micrometer and nanometers. Think of, if you go way back when, there was a iPod that was really, really, really small. And what was it called? It was a nano iPod, or iPod Nano. Now, why did they call it a nano? Well, because it was really, really small, and a nanometer is really, really small. Why didn't they use micro? Well, if you go back and look at that thing, I think it had a gigabyte of memory. Well, a gigabyte up here, way up there, that's a billion. Well, the opposite of that for a billionth was a nanometer down here. So they utilized nano to match up with the idea of billion, and it's a billionth. So again, I'm pointing out that businesses are the ones that are trying to, not trying, but they're the ones that are switching us over. And why are businesses switching us over? Remember I told you that all these other countries in the world use the metric system. Well, if I'm running a business and I want to sell stuff to other countries, and I want to utilize the same system. So it makes more sense for business to utilize the metric system to sell to a whole bunch of countries than to utilize the English system so they can sell to just America. Right? We can increase how many people we can sell to, and more people we can sell to, the more money I can make. Right? And if I utilize the metric system, then more people are going to understand what I'm trying to sell. So we are going to see the metric system more and more and more. Okay? And it's going to show up in the businesses, and that's going to be the ones that are going to get us to switch over, which is already starting to happen. And like I'm trying to point out to you, you guys already know the idea of the mega gigatera out there. Right? Because of utilizing phones and computers. All right, well, now when we look at the concept of the metric system, and again, we can change things. Let's go with, and this is where your homework comes in. If you have 4,000 milliliters, I want to know how many liters that is. Okay? The way in which I like to teach this is, you always start with the one that's got a number. Well, there's a number, and you look at the units, which is ml. Well, this is milli, right? And milli happens to be right here. So I'm going to put a little star in front of that, right? That shows where I'm starting at. What am I trying to change the milliliter into? I'm trying to change it into liters. Well, what's liters? That's the standard. There's just liters. So I'm trying to get to here, and I'm going to put a question mark there. Now, how many jumps on my scale is it to get from milli to the standard? So it's actually 1, 2, 3. It is 3 jumps to get there. So that means my decimal is going to make 3 jumps in that number 4,000. Now I got to know, okay, well, where is my decimal to start with in 4,000? Well, it's right here. All right. And then notice, and I didn't make this scale going straight up and down, nor did I make it go straight across. My concept of making this thing like a stair step was to show you that those up there, those guys are bigger. These guys down here, they're smaller. But also it shows that my decimal is going to go from here over to here. So it's actually jumping to the left. So it's going to go from here, it's going to go 3 jumps. 1, 2, 3. And now, instead of 4,000 milliliters, it is 4 liters. So 4,000 milliliters is exactly the same as 4 liters. They are equal to each other. It's just a conversion of one to the other. All right. Well, let's do another one of these before I have you. Ultimately, then you're going to do this as homework. So let's give you, we're going to go blank meters equals 0.02 kilometers. So again, you start with the one that's got a number. All right, well, there's my number. Oh, wait, it's not the first one this time. It's the second one. You're always going to the one that's got a number. That's what you know. And it's kilo. So we're starting way up here at kilo. That's where we're starting. And we are going down to M. Well, M, oh, is that milli? No, it's not milli, because milli, it's got to be milli something. That's what the blank. It's got to be millimeter, milliliter, milligram. It's got to be one of those standards. So if we have just an M all by itself, then that means it is meter all by itself. So that means it's the standard. That's what we're trying to change it to. Now, how many jumps did we make? We go from the star to the question mark. 1, 2, 3. We went 3 jumps again this time. Did I go to the left? No, if you look at it, we started here and we ended up over here. So this time we went to the right. So that means my decimal is going to go 3 jumps to the right. So it's going to go 1, 2, 3. So I need a 0 in there. So this becomes 20 meters. So 20 meters is exactly the same as 0.02 kilometers. It's exactly the same. Now going back to what we talked about earlier in this video, or the other video, was the idea of changing things in the English system and the idea of the football thing, and how we had to go from 3.5 yards to 126 inches. That takes a lot of mathematics. This one, all you got to do is simply move that decimal in order to get from one place to another. Right? Now, if you're way up here at mega and you want to jump down to kilo, you do have to add in those jumps right there. You got to add in those blanks, right? So you may want to add those in on your notes so that you have mega, giga, and tera. And again, it's you've got to make those jumps because those are either multiplying or dividing by 1,000, which is a multiple of 10. With that, then ultimately you're going to end up doing some questions coming up in the next day or next few days. And this is what you're going to have to do in those questions is change things from one unit to another. So we'll see you.